All right, good morning. Everybody awake? Sorta. I don't see like everybody jumping up. Don't make me play the Baby Shark song. I will play the song and make you guys get up and dance. So, we're going to start chapter 3, and there's a couple of problems with what's going to happen in the next week or two. What are we doing on next Monday? Labor Day. Are we here in class? No. And then to make life more miserable, the week after that, the 14th, are we in class? Everybody should go, wait, that's when I have to miss class. So I get to go visit with a neurologist. It's a fun process, apparently. So they don't schedule around us, as far as I can see. So you guys are going to miss the next 2 Mondays. Everybody want to give a round of applause for that? Yay. So whatever we talk about today, we're not going to see again until Wednesday, and then I won't see you for another Wednesday. So one of the things I'm going to do is probably do a pre-recorded video for you guys with some lecture, some content, some excitement, and maybe I'll do it from somewhere more exciting than my office here. I'll do it from my office at home. Isn't that exciting? Trying. I'm not going anywhere very exciting in the next couple of weeks, so. So, hopefully you guys have all read chapter 3. And here's my question, and it's hard to tell because I got about half of you gone already. How many of you have had database 420 already? One person. So I'm going to guess by extrapolation, maybe 2 people total. How many are going to take it in the spring that are in here? How many are going, database class, why do I want to take something like that? Well, when employers go out and they start looking for skills, one of the skills they say is, we want you to be able to use Excel, we want you to be able to use a database. They want you to be able to manipulate those databases and find information. So, all right. Well, how many of you have ever used a database? If you've used a database, raise your hand. Oh, wait a minute. Let me come back again. How many of you enrolled in classes this year? Same number of hands. When you enrolled in MyPSC, that's a database. And we're going to talk about how it works and some pieces to it. But it stores data. We manipulate it. You're enrolled in classes. You've used the database. How many have shopped at Amazon.com? Yeah, everybody has. Who hasn't shopped at Amazon? It's the reason Jeff Bezos is the single richest person in the world right now. Estimated net worth of $200 million or $200 billion. And that's after he just got divorced and gave away half. $200 billion. Holy cow. Holy cow. To put that in perspective, what do you think the Peru budget is for a year to keep Peru open? 100 million? How about $15 million? That's all this college costs. And that's still a lot of money because I don't have it in my pocket. But this college costs about $15 million to run a year. Jeff Bezos, $200 billion. To really put it into perspective, though, let's put it in something that most of you, if you're native Nebraskans, know and understand and are going to miss out this fall. What is the football budget for UNL? For the budget for the football team. Just the football team. You guys can Google that and try to figure out a number for it. This year might be a little different. How many? Oh. Huh. wait a minute, there's a difference there. Whole budget Peru, $15 million. In fact, to make you guys feel like you're the shavings off the bottom of somebody's shoe, if I add Wayne State, Chadron State, and Peru State together, we don't amount to half of the budget for the football team at UNL. How does that make you guys feel? Good, because you're, oh, okay. All right. So noted.
But also look at how much money the football team brings into Lincoln economy in the state.
It does bring in some money to the economy, although there's some accounting irregularities, I think, if you really went through the process. But it's a demonstration of how some of these things affect it. The whole college? UNL's budget? So you got to look at, there's grant funding, but I think their budget is a little over $1 billion total. It is the largest expenditure in our state in a lot of regards, but do we get a lot of good out of spending money to educate students and research? I would hope so. If you're shaking your head and you're a college student, we need to really examine that. Do we get a lot of good out of the money that comes to Peru? So about half of our budget comes from the state, and about half comes from tuition and other sources. Is it a good thing to have college-educated students in your state? Yeah. Is it good to then try to keep them in the state? Even better. So we got off track there a little bit, but UNL's budget is a little different. So it's been eye-opening because I've gotten to see some sides of that because my stepson is an athletic trainer, went to UNL, got his athletic training degree from there, certificate, and he worked with the football team a couple of semesters or seasons, and we got the best tickets ever. I was not above the 5th row up, basically on the 50-yard line, because he got free tickets as a student athletic trainer. And the amount of swag they got as an athletic trainer, because they had to have the same uniforms, the same gear. It was thousands of dollars in gear every year. He then says, well, I want a graduate degree, and he heads up to South Dakota State, up in Vermilion, South Dakota. Well, they have a football team, and honestly, they have a reasonable chance of beating UNL at this point, knowing their success. But the budget was a little different, and he's like, ooh, it's a whole different world. He was so spoiled and inured in that he didn't understand those differences. Now he's trying to get on with, he's going to finish his graduate degree, and he started some, I don't know, he's got some blog stuff he's doing and some websites for athletic trainers, and he's been in communication with the athletic trainer for the Kansas City Chiefs on several different things. And the guy just emailed him yesterday, and he texted me a picture of the ring that they got for the Super Bowl ring. And the athletic trainer got one too. $40,000 ring. It looks like a watch on your finger. It's so huge. Weirdness. We're all in these weird times. All right, so let's talk about databases, though. Let's get back on subject. You guys have seen databases. You've used them. You just didn't realize in some cases what they were. So we want to talk about what they are. How does data organized in them? And we're going to give you, in about a week worth of class lectures, what you're going to take an entire semester to take if you take Database 420. And conversely, you could get a degree in some institutions on database information. We're not that detailed in here, but I want you to understand what we're looking at and some of the pieces that are in there. There is career fields in this. If you are a database administrator, you can be in very much demand. Gene Beardsley, our Director of Information Systems at our college, that's what he has a degree in, and that's what his proficiency is database design. There's careers in it, and they start out paying really, really well. There is demand for this. So a database is really just a way we organize data. So You do it at your own house. You organize all your bills. You've formed a manual database. If you put them into an Excel spreadsheet, well, now we're getting a computerized list. And then if I had a way to sort them, sort of like when I go to Amazon and I pull up my order history, and it says, in the last 6 months, you've placed 72 orders. Well, I got to stay off the Amazon. That management, using some system, we call it a database management system. And there are all kinds of them out there. The most common one you're going to see at your desktop is something called Microsoft Access. And so you were introduced to it in 101, and you probably went through the lessons and went, man, I'm never going to use this crap again, right? You can shake your heads and go, yeah. And it was interesting, but we didn't deal a lot with it, and we don't have enough time in the 101 class to get into a whole lot of detail. So a database management system. So that software. So we'll use Microsoft Access as an example. There's other ones. There's SQL databases of all different kinds. Oracle has some. And we're going to talk about how they manipulate that data and its users. How does that work? How do I manipulate my data around? So we're going to go back to chapter 1. Data is raw facts. It doesn't mean anything. Information then is when we've organized it and made it useful. Well, the same way with Amazon. When it takes data about people and says, hey, I need to figure out a way to send out ads to targeted people, then we organized it into useful things. When I find out about college students, maybe I want to figure out how to keep students in college longer. So that Bobcat 360 you keep getting emails about and different things. And if you start missing class, you get emails from it. Or you get a bad grade and you'll see an email from it. That's a system that we're using to try to track how students operate and they think. And we're using a database. Bobcat 360 is a database. And so we're taking raw information, students' grades, student information. I think they make you take a survey every year in Bobcat 360, if I am correct, and maybe not. I know they do as a freshman, but I do not know if it continues. But we're trying to figure out, do you have the study skills? Do you have the self-reliance skills? So we're taking that data, we're manipulating it into something that's usable. How do I then target you as a student to try to make you more successful? So data. Data, the simplest form of data we have is something called a bit, a BIT. And a bit is a 0 or a 1. All these computers in front of you, your phone, your watches now, all of that are really dumb, are really, really dumb. All they know is 0 and 1. Your computer, when you say the word digital, says, oh, it's a 0 or a 1. That's all it is. Well, 1 isn't useful. But if I put 8 of them together and I make a byte, a BYTE, a BYTE is 8 bits together. And with that, we can then start to form something. 1 byte, BYTE, is big enough to hold 1 letter, 1 character, 1 number. And so it becomes useful. When we put them together in bigger groups, we move to something called a field. So a field then says that is an item, so a name, a number, information, a group of characters. When we put a group of fields together, so now I know you as a student. I have a NUID, I have a sex, I have an address, I have a permanent address, I have things about you. That forms a record. And then finally we move to a file. So that is all those records together. So all of our student records put together become a file. And so they call that hierarchy of data. So it really moves from tiny pieces that don't mean much, a 0 or a 1, all the way down to an entire file saying, hey, we've got 1,200 students, and each student has a record, not a criminal record, just so you don't know that, but a record, and that forms a file. So we got to think about it in terms of size that way. So this might be another way to do it. Some people learn better graphically. So here, this is that byte. 8 bits. So notice it's zeros and ones. And if you do the math, it's 2 to the 8th power. Well, 2 to the 8th power is 256. So 1 byte, B-Y-T-E, has the ability to have 256 possibilities for data. Well, we can shove the alphabet in there, and we can shove in some numbers, and we can shove in a few other things. So that's where it becomes useful. It's really the first thing that's useful. So in this case, 100000110 in binary is actually the letter F. And so there is a table called ASCII that says, this is all those values, this is what it means. So we have to have some translation. So then we have a field above that. So there's a last name. And then a record says, here's our student ID, our address, a name. Finally, we get to a file. So that is all those together. And then that database is even bigger. That database says, well, not only do I have students, but maybe I have faculty and staff and other information all put together. So we go from tiny to, in some cases, very, very large data sets. Think about the Internal Revenue Service. So they start with data in their database, and they start with this idea of bits and bytes, and they all go all the way up to a database that's got everybody that pays taxes. Is that a big database? Yeah, it's huge. Huge. If I think about Amazon, they start at the bottom, and then they have a database storing everybody who's bought anything at Amazon. It's huge. The amount of data we have is huge. So then we can break it down a little more. So we break this data down, and so each field can be something, an entity, a thing. So a person, a place, a thing. So in our databases at Peru, you are an entity. You have not just a number, but we have other things about you. And one of the things we have is we have an attribute. So if I have an entity student, are there attributes you guys all have? So let's think about those attributes. So I'm going to put up here, and maybe I'll throw it up on a Word document so it's easy to see since I can't really write on the screen right now. So let me throw up a Word document. And I'm going to say, well, you guys are students. That's our entity. What things do you guys all have as an attribute? What can I put down for an attribute? Your what? So you might have a major. Might have an age. Do you guys have a hometown? So a hometown address or a permanent address. Maybe you have a temp address or school address. So there's lots of pieces in there. What about an NUID? So it might have a driver's license. Email. So there's lots of pieces in there. Phone. Credit card. It might be interesting to store that. I don't know if we actually do. All right. So we have lots of things about you. Maybe we have your eye color. We have all kinds of information about you. Well, here's the question. So in our database, we've got a record about you. So every one of you, we have a record about you. All this information is stored in there. Your major, we don't really store the age, but we'll talk about that later. Your addresses, all this information. Well, how do I know it's you? How could I tell one record from another record? What lets me do that? So let's get the most generic name we can possibly put in there. So let's put a couple of these together. So maybe we have let's say we have James, I can't talk, James Smith, and we'll say he's 37. We think he's male. He's got a Auburn address, an NUID, a driver's license, an email. I have another person. Is James Smith pretty common? Oh. So I have another James Smith who's 19. Male. They're from Seattle. They've got an email also. How do I tell those two records apart? Oh, so we could use something like NUID. The email address might be different. So Social Security number might be different. What we're looking for is something called a primary key. Some way that I can say, all right, this is how I can identify this record. And so what we look for is something that is unique to that record or that group. So, can we use Social Security? It should be unique, but what do we have here as a college that's interesting with Social Security numbers? Do we have people without Social Security numbers? Oh, great. So, but what do we generate for every college student that is unique? We issue an ID number. And we say this is unique to every college student that we have here. So it's our primary key. It's how we can go into that record and say, I want only the James Smith that comes out of Seattle, Washington. And it's linked to that primary key. It's that field that says I am unique. Now, there are times we use two or more fields and put them together, called a concatenated key. And we say, I want, maybe I am looking by names, and I say I want the Smith that's from Seattle with blue eyes. And maybe that narrows it down. But when I design these, I want to design it so that that primary key is unique for every record. In fact, that's the whole basis for what we're going to call a relational database. So databases are off on something like Tinder, only it's inside their system. They're dating each other. They've got a relationship. That's how we move data around, is through these relationships. So we have to have a primary key, something that is unique. So most of you have a car in here. Is there something on that car that is unique that can let me know what that car is? The VIN number, yeah. So I go out and I buy a computer. Is there something on that that tells me it's unique? Well, no, well, that is, you're in my, so the MAC address is unique, but usually on the bottom of any device, they have that serial number was where I was headed. So when I go and I call Peloton about my crappy Peloton bike again, by the way, anybody here seen the ads for Peloton bikes and they look really nice and they're expensive? Anybody in here have one? Good, don't buy one. So when I call in Peloton, there's a serial number addressed to that bike that says, oh, that's the individual, and then they can look up my record and go, oh, this is the 4th time in less than a year that you've broken your bike. We should probably try to fix that for you. So that primary key becomes important. We have to have a way that we identify things in our database. So if it's a car, if it's an insurance claim, there will be a key address to it. And you'll see those. If you go to the doctor, and in there it'll be, hey, here's your claim number for that visit. And that's how they identify that's you and that's that visit you just had at the doctor. Your order number at Amazon. Every one of those is unique so that, oops, clicked outside of my box. So, keys are what we do to identify. So here we have employees. Everybody's got an employee number. Last name, first name, hire date, department number, all those other attributes tell us something else about that person in this case. So notice though it's got hire date. Why don't I have number of years on the job? Why would I do that? Why do I put the hire date in there? Why wouldn't I put in there, hey, this guy's been on the job 10 years? What's the advantage of putting a date in there? Well, the longer they've been there, probably the more experience. But what is the advantage in my database of putting in a date instead of an age or how long they've been there? I can sort it, but think about this. If I put in my database and I put in an age and I said, this guy's been there 10 years, this guy's been there 4 years, this guy's been there 3 years, is there any way for that to update automatically? Correct. But if I have the date in there, is a computer smart enough to subtract today's date minus a date we put in? And so it could tell us that age every time. So data that we can calculate, we tend to do it that way. So here, I know this guy's been there since 1995. Our computer's pretty smart, and it can actually take that today's date, and it can subtract that date and say, hey, they've been here 12 years, 19 days, or whatever it happens to be. So we try to put in data like that if we need to calculate it. So things that are going to change, ages, for example, we put date of birth in there. We don't put in what your current age is. Because then we'd have to figure out some way to go in and update that, and we don't necessarily want to do that if we can avoid it. So, way back when I was a child about this tall in the 1970s, the traditional way we dealt with data was we had a file for every individual system. So, student records would have a file. Over here would be another file for payment. So, what the databases did when Boyce Codd came out with this idea of these relational databases was it gave us the ability to start pooling that data together. And we could, instead of having one little file over here, and one file over here, and one file there, we could start putting that data together to make it usable. And so all those pieces got put together, and now data's a little better than what it used to be. There are still times it will drive you crazy. Going to the doctor's office is one of those. The first time you go in a doctor's office, what do they hand you when you walk in as soon as you try to sign in? They give you a clipboard with about 12 forms in it, don't they? That's that idea of distinct data. Because when you start filling out the forms, are you filling out the same thing over and over again that goes to different little areas? Yeah. And the first question you might even really ask is, why am I filling this in by hand when they could have sent me to a website to put all this data in for me, right? Because if I put it in by hand, does somebody else then have to take that data and transcribe it over? So it's not a very efficient process. And I will tell you, by the 10th form, I'm just starting to make crap up. Are you pregnant? Yes. When's your due date? I don't know. And I can't help it. Sometimes I get in trouble for that. So I can only imagine what the med center up at the university now thinks, because they left me alone the other day with like 12 forms. Yep, I've done that too. I am an avid skydiver. I put all kinds of strange stuff just to see if they noticed and paid any attention. So at various points on that form, I switched sexes, I switched races. At some point I asked, why does it matter? Because I wasn't sure what my race had to do with the fact that I'm getting an MRI of my head. Didn't seem to make any difference to me, so I was kind of a little lost. But that's that idea of that each data piece is separate. We want to put it all together. So not only is my MRI data in there, the data about me is in there, the billing data is in there, so they can make sure they bill that. They've got information about my insurance company, so they can make sure they bill the insurance company. And we put all those pieces together. And to do that, we need that thing we call a database management system, DBMS. So we will abbreviate it from now on as a DBMS. So here in a company or a university or any large industry, we want to put all these things together. So we want to know, from the management side, we want to be able to pull reports and see what's going on. So here at the college, we want to pull reports and see how many students are enrolled today. Because our funding is directly tied to student enrollment, so our ability to serve our students is tied to that, so we want to be able to pull reports. And if suddenly we have students dropping out, we want to know why, so we have reports. Inventory control. Well, we don't do a lot of that here at our college, but think about Ford or somebody who's got a lot of pieces of inventory. They want to be able to manage that. Invoicing. Well, you guys have seen that. Do they send you a bill very quickly at our college? Yeah. But does any business, do they want to be able to send a bill pretty quickly? Yeah. That money flowing in is how they continue to operate. But more importantly, if you're an employee, what is the most important thing you can get? Paychecks. And I will tell you, having worked in IT and other areas, the worst thing you can ever do, if you're going to do work on their system or do some work for a company, make sure you do not screw up payroll. Do not. They will be hounding you with pitchforks to make sure that you get payroll out. But do we also get other things other than checks out of payroll? Do we need information? Yeah. And we put in things like those checks and balances. Traditionally, we try not to pay employees if they're no longer working or they're dead, right? Sometimes it's hard to tell the difference between the dead employees and just the not working ones, right? Okay, that was funny. You guys can laugh. You guys are all like, oh man, this is hard stuff. I'm scared now. So, we have some considerations we need to think about when we start to look at a database system. What data are we going to collect? Are there things that we need to collect that we're not? And does that data have a cost? So the more data we store, the more data it's going to cost. Does not including data have a cost? So let's go back to our University of Med Center, and I'm putting all these weird things in there. Did I possibly cost that Med Center data because they're getting federal grants? It's possible, because they can't use that data I put in there. Maybe there is a valid reason why they needed to know what my race and ethnicity was for me to do a brain scan. Maybe they're getting a federal grant for over 50-year-old white males If you do a brain scan, they get an extra $100. So what data do we need? Access. So who gets access to that data? And why? And how do we justify it? So MyPSC is a great example of that. You have access to your own records. But you don't have access to your roommate's records or your buddy's records, do you? But as a faculty member, I have access to everybody's student records and see their grades. I can do that. But I can't get into financial aid's records. I can't get sensitive financial aid information and find out that. So it's segmented, and we've looked very carefully about what data needs to go where and to whom. So what users can get that data? And then how are we going to physically and logically arrange that? Where are we going to store that data? Do we want to store it here on our campus? And I will tell you, we store very little on our college campus. Your MyPSC data isn't stored here. It's actually stored at Lincoln and in Omaha as a backup at the Med Center. So there's a data center at UNL. They've got a backup setting at UNMC. That data doesn't stay here. It's physically located in two different areas. Well, why would we put it in two different physical areas? It's stored at the university. That's probably good enough, isn't it? Security? What if they had a fire in the building it's in? Or a tornado? Then it would be lost. That's why we have that backup piece. And then we have to think about archiving that data. How long do we store that data? So if I'm a business, I probably have rules based on IRS rules that I have to store data for so many years. Here, we have other rules. So student data. Can we ever get rid of student data? So your grades and your transcripts, can we ever get rid of them? No. In fact, if you filed an information request for your great-grandma Bertha, who went here in 1809 or whatever we started, those records still should be here somewhere. And certainly since we've become computerized in the mid-'80s, that data is all there. And so when we moved to MyPSC from the older system, part of the thought process was, how much data do we have to go back and put in? How long do we need student data? So our average college student's probably under 30, right? Do we have students over 30? Chris left, so I can't make fun of him now. But we've had students that are in their 70s and 80s going back to school. Do we need to keep all that data? It is important. It is important. And so we have to figure out, well, how long do we want to keep it? And then, oh sure, now he comes back after I make fun of old people. I'm glad you got broad shoulders, so I can, because you're as old as I was when I went back to school. So how do we deal with security then? How do we protect it? And you had a good thought already about that security, why we put it in two places it is for security. We've implemented something now that's it seems like a pain in the butt, but it's another way we secure it. That two-factor authentication you guys are having to do now. Is that a pain because you got to have your phone? Yeah, or another device. And I've ran into an issue. I was an idiot one morning. I ran off, came over here to school without my phone. And the way I have it set up, the only phone number it calls is my cell phone number. So I had to call from my office number and call my wife and say, hey, my phone's laying on the desk. Yeah, here's the access PIN code for the phone. I'm going to authenticate in so I can get into Blackboard. But it's that idea of, how do I give another layer of security? How do I protect that data? Things inside of Blackboard are important. Things inside of our MyPSC are important. And so we model these. We start putting together some models of how we're going to start doing that. We have to have some way we can sketch out how we're going to store all this data. So we have some ideas. We think, oh, I need all this information from our students. I need to know your home address, your permanent address. I need to know payment methods. I need to know how many hours you plan on taking, all this stuff. So we're going to use something called an ER, Entity Relationship Diagram. So we use a lot of symbols. We understand symbols. We understand it. So this is that idea of how do we start modeling. So the data model supports the system, which supports the whole business. So what we create supports everything we do on our campus, our payroll, our MyPSC, which supports that entire enterprise, college education in the state of Nebraska, essentially. The only people not using MyPSC are the private colleges and the community colleges in our state. Now that's kind of a nice thing in that some of that data can migrate. So if you come from UNL and you say, man, that's not for me, I'm going to come down to a smaller school, or vice versa, you come from here and you go to UNL, some of that data can migrate because it's all based on that NUID number. And so we can also have some things where it doesn't work as seamlessly as I would like it to, but maybe you need one class to graduate. We're not offering it that semester. You could take it at Wayne or Shadron because we're sister colleges. It doesn't work quite as easy, and there's some federal financial aid stuff that gets in the middle of that. But so this is an ER diagram. ER diagram. Not emergency room, entity relationship. And so this is really like when we take a sentence and we start diagramming it out. You guys remember those from grade school where you had to go, man, that's the participle and and all those things. Well, this is kind of similar, but this actually makes sense. So a couple of things to look at on here. These lines, notice there's a couple of different types of lines. So there's a line that has a crow's feet, and there's just a single line. Oh, okay. So we're going to get into what those mean. But look at it this way. We also have verbs in there. So an invoice generates an order. The customer places an order. The salesperson serves a customer. The orders include items, typically. And then the item specifies a product. So there's a lot of information in there to show how that data moves around. How does that data move from one place to another? So this is a typical sales resource that we're going to use. So that's an example of an ER diagram. We also have what's called a relational model, and that's where we really get to the heart of the database, is this idea of that relational model. So this is going to look a lot like a spreadsheet to start with. So I want you to be aware it's not a spreadsheet. These are relationship models. And so I'm going to look only at, to start with, this bottom model, this data table 3. So the relationship part comes from the fact that we can go from one table to the other, and I'll show you how that works. But let's look at this first one here, down here on the bottom. I know I'm going backwards, but I can't reach all the way to table 1. I'm short. So data table 3. What's the primary key there, or the identifier for those records? Social Security number. Perfect. So when I say my Social Security number is 005106321, it specifies that record or a row. So sometimes we call it a record, sometimes we call it a row. It specifies that particular item. So when I go in and I say I want this Social Security number for John, Francine Johns, it's got other information. It's got their hire date, their department number. So it's got a lot of information in there. But I'm going to go to the table above that really quickly. And notice that one is based on, it says department table. So typically we always put that primary key on the left side just to make a convention and make life easy. So if that's the case, what is the primary key in that table? If the leftmost column is the primary key, then that department number would be the primary key, right? And then if I go all the way up there to table 1, the project table, and I use that same convention, that's the identifier for that is project number, or the primary key. So 3 tables, 3 primary keys. Okay. But here's what I notice. Is the primary key from one table, does it live in another table? So if I look at project up there, does that project, which is the primary key in table 1, does it live in any other table? In this case, do we see it anywhere else? So we don't see that one anywhere. But when I look at department number, do I see that in another table? Yeah. Do I see it in table 1 and table 3? Yeah. So maybe there's something weird going on here. So if I look at this table, this entry for Francine Johns, and I can see department number here, so she's in department 257, I can look up at this table for table 2 and say, department 257, that's accounting, the manager of that department, and it gives me that Social Security number. I can then go down here and go, this manager, she's the manager of that accounting department, right? Interesting. So when a primary key is in another table, that's how we put them together. When it's in this table, that Social Security number, so table 3, it's primary key. When it shows up in table 2, it's what we call a foreign key. So primary key identifies a record. Foreign key then is the primary key for another table that we're going to use to link those items together. All right. And so notice all the way up at the top, department number is a foreign key in table 1. So I could even then link department 257 payroll into a specific project. So I can interconnect these tables together. I link them together. There is a relationship between table 3 and table 2, and it's based on foreign key, primary key. And so where they are equal, I can say there's an example of that. So here, department number 257, department number 257, I can match those columns up, and I can say, all right, now I can get some additional information. Well, that doesn't seem like such a breakthrough, but it really is. Because it allowed us to put that data into multiple tables so we can separate it out. So we have a couple of operations that we're going to look at. So we have what's called a selection. And by selection, we can put in a criteria. So we can put in a criteria. So let's go backwards so we can look at one. So here we have a table. I can put in a criteria that I only want employees or managers in this table that were hired after 2010 or something. If I put that criteria in, does any of those fit? After 2010. Yeah, just one. So criteria, when I select something, I'm able to put in criteria. Projecting says I can eliminate columns. So selecting goes horizontal. Projection is vertical. I'm taking out columns. Joining says I'm going to smush two tables together. And I do that through that common data attribute. So what happens between one table and another one, I have to have some way to link them together. And the way I link them then is that common attributes, that primary key and foreign key, I put them together. And when I combine all these techniques together, I'm able to extract data really, really easily. So we're going to jump back to our ER diagram. So here we have a manager, department, and project tables. So the manager supervises the department performs or works or does the project. So we got those little crow's feet to think about. If I think about this just logically, can one manager, can they manage many departments? Have you ever ran into a business where you had a manager over several departments? Okay. And can one department perform multiple projects? So this might be some kind of indicator of values in there. So one or many. So we're going to see those again. And then this is that idea that we were talking about, how we're going to link those tables and data together. So if I think of them as chunks of data, now I'm taking, in this case, they said, all right, I want the department description, sales manual leads to the department number in the project table. Sales manual, 598. 598 leads to here, leads to this manager, which leads down to here. And so we can link these tables together. So we can do queries. So when we use the term query, a query is just a question, but that's what we call it in our database. We're performing a query or a question. So we want to find out things. In this case, we want to find out who is actually in charge of this project. And so we have these different data tables, and there's a reason we put them in different data tables, and we're not quite there yet. So, have all this data. We've built our database, we've got all these things in there. Then we have to figure out how we clean up our data. So there's a saying in the IT world called GIGO. Garbage in, garbage out. So some way we need to scrub that data and come up with the correct data. So I turned all those forms in to UNMC. And I should probably apologize to anybody that works at UNMC for what I did. They had to clean that data up. And they had to say, well, I don't understand. On this paper, he's a white male. Now he's Hispanic. Now he's African American. What is going on here? So that data cleaning, how did they scrub it? Well, I am sure that at some point they just looked at the first one and scrubbed that in. So I don't know what I'm going to. It may be interesting when I go in there. We'll see what happens. How do I clean that data? It's expensive. Think about Amazon. They generate 1 million records an hour of sales. They have to clean that data up because there is some bad data in there, guaranteed. And they don't always have processes to clean some of that up. So, as an example of that, Home Depot. Everybody knows what Home Depot, the big orange store, is. I ordered a shower enclosure for the house in Auburn. Glass doors, weighs a ton. And I ordered it, and for whatever reason, because I've ordered a lot of stuff from Home Depot since then, but all of a sudden, this several $1,000 shower enclosure. I see, oh, it's shipped, and I just happen to catch, why is it going to Lane Street in Falls City? I haven't lived there now in 10 years. It's my ex-wife's house. Why is this shipping? And at some point, they had scrubbed that data and decided my new address was not right. Somewhere there was an entry that said, nope, that's the one we're going to look at. And so when they went through and cleaned that data, they did that. It was a pain to fix then. But how did I clean that data? I had to go in and manually clean mine, but the company goes in and looks at all that data, and it does things like they buy lists, databases of known good addresses. So when I put in my name, it said, hey, this is the address you should be using, and it tries to match those up. It goes to the post office and says, these are legitimate addresses, these aren't. Amazon does the same thing. They look at addresses and try to maintain those. How do I do that? Data cleansing is high. There's a lot of data. How do we cleanse it? Now, there's another term in here called data validation. Data validation says when I'm putting in that data, it's already going to hiccup. So if UNMC had a computerized website, and they handed me a tablet, which I know in COVID, they're probably not going to do that at this point, but if they had said, hey, will you go online and put in all this data for your MRI? Data validation would have been at that point in time, it would have triggered and said, hey, you entered different pieces here, here, and here. Or it wouldn't have ever allowed me. It would have transferred that and not allowed me to. It would have validated that data. It would have said, oh, no, you couldn't have been born in 1862 or whatever it is I put at one point. It would have said, no, clearly you're not 192 years old. So data validation is done at the time of data entry. So that's when you put in something into Amazon and you're trying to ship it to an address, and it goes, that address doesn't exist. That's data validation. It does it at the time of doing it. So data validation is at the time, and it's actually cheaper because I don't have to go back and look at old data. But data validation is putting in things to make it fit right. When you go into a form and it makes you put in your Social Security number and it makes sure that you have all the digits in your Social Security number, that's data validation. When you check out a MyPSC and it says, do you really want to register for 92 credit hours this semester? That's data validation. Or if it looks at it and says, hey, you've enrolled in 2 classes that are at the same time, I'm not going to allow you to do that. Data validation. It can't fix everything. So I had a couple students this semester, and I will say that COVID has made everybody's brain fuzzy. Would everybody agree? We're stressed about it more than what we'd like to admit. We're not sure what the heck's going on. And I had a couple of students who are online students enroll for on-campus students. It's not smart enough to know that because we've never said, I'm an online-only student, and it would flag if you take an on-campus course. But we've had some issues like that because we can't validate everything. But the more things we can validate, so think about Amazon. Do they want to send out things to the wrong address? No, it's expensive for them. Because somebody pays for those packages that get misdelivered. And there are areas, for example, in their data validation, if you've lost 12 packages to Porch Pirates, are they going to stop shipping to you? Porch Pirates. Should I try saying Porch Pirates? That's kind of hard to do with a mask on. But they're going to eventually say, oh, on our data validation, you're not a good customer. We're not making money off of you. We're going to quit shipping to you. And I see that happening in the future. They're going to start saying, oh, no. Or even better, because when you sign into Amazon, they're going to recognize immediately that you've been the victim of Porch Pirates. And what are they going to do to the prices of the items you buy? They're going to raise that price up a little bit, right? And we have the tools now to do that price discrimination in our database where we don't all pay the same price. In fact, I will guarantee right now, if we log into Amazon, we're going to find items that every one of us pays a different price. And from economics, you're going to find that's called fourth order price discrimination. In other words, you're going to pay a higher price based on your circumstances. We already do that in a lot of businesses, and it's based on the idea of these databases. Does everybody in here have car insurance? I hope if you have a car, do you have car insurance? Yes. I hope the answer is yes. Does everybody pay the same price for car insurance? No. No. And it's in that idea of we search that data. And there's a lot of factors that are going into it. And there's some new ones that they're actually looking at. The latest thing they're trying to do to predict your things like credit score have nothing to do with what you've bought and haven't bought. It's they're trying to look at social media and make associations with social media. And the assumption is, if you have friends with crappy credit on Facebook, you probably are going to have crappy credit. Does that seem fair? Just because you pick your friend. But they've found that it's actually a better predictor in some cases than what you've done in the past. It's who you associate with. Great. All right. Read chapter 3. Make sure you have read chapter 3. It is not the easiest read in the world, I will say that. For this week, where did I put it? Did I log out of class? Nope. I threw it on the other window. For this week in class, there is an assignment and a short quiz. So the quiz is actually back over chapter 2 and 1. So you'll have to review 1 and 2 really quickly. There's 20 multiple choice and true-false questions. Shouldn't be that horrible. There is a case study for you to do by Sunday. At the end of your book, and I even printed out the book and brought it in so you could see it. So there are 2 cases at the end of the book. You can pick either one of them to do. And then at the end of the case study, there are 3 critical thinking questions you need to answer. So that is the assignment for this week, is that critical thinking. So these are out of chapter 2. So we're going backwards a little bit to refresh. And so there's a couple of really good cases there. So you're going to have to read and look at those. If you do not have the book yet, please email me and I will try to scan this and send it to you so you can turn in this case. Hopefully everybody has their book by now, but I know the bookstore, and at least in one case or a couple, has been very, very slow in sending those to you. So the other piece I want to look at is we talked about open source, we talked about in the cloud. Here's something I find really interesting. So most of you have heard of this little tiny company called Netflix. Most of you have heard of Amazon. So several years ago, Netflix moved all of their operations, except for the actual video streaming. That sits in some specific areas. But they move almost all of their stuff. So when you log into Netflix, the website, you're logging into an Amazon web server. Does that seem really weird to you? Because what can you also get at Amazon? Does Amazon have Amazon Prime videos? So why would Netflix say, hey, we're going to do our infrastructure in Amazon, in their cloud system? So it's an interesting read. I encourage you to read it. It's a couple years old now. So this was 2016 when they did this. But when we look at what sits on Amazon Web Cloud or their Amazon Web Services, and we look at Microsoft Azure, that's about 80% of all the websites and things you're going to see out there. It's pretty crazy. In fact, Blackboard is now hosted. They've moved Blackboard out of their own data center in Virginia into the Amazon Web Services area. And part of the reason they did that was that way they didn't have to build multiple data centers on their own. But Amazon has a huge stake in this market. But it just seems interesting to me that Netflix would say, hey, I know you're our competitor, but I'm still going to use you anyway. Does that seem weird to anybody else? So, it's an interesting model. So the only thing, and I think they've actually moved that out now if we did some more research, was the only thing that still used their own data center was the DVDs themselves. You can still get DVDs from Netflix. Did you know that? You can sign up and they will mail you DVDs still. Yeah, so they still do that. The market's diminishing, but the weird thing to me, and because it happens to do to those streaming rights, you get a lot more choices in movies off the DVDs than you do off of what they have on streaming, because what's on streaming is limited by some of the rights they've negotiated with different people and organizations. All right, so you have an assignment, this case study. You have a quiz to take. Do not show up here on Monday. I won't be here. You guys will be sad. The college will be empty. And then we're going to meet Wednesday, and then we're not going to be here the 14th. But the 14th, I will have something in lieu of me being here. I had to promise them that, even though I'm taking a sick day. All right, any questions? Comments? Gripes? Complaints? All right, let's get out of here for today. Go enjoy the beautiful day.